Hello everyone. In this video, we will have the equation of the tangent line. So for example, you are asked to find the equation of the tangent line to f of x equals x squared plus 1 at x equals 1. So this is the graph of f of x equals x squared plus 1. So that's a parabola with vertex at 0, 1 and opens upward. So at x equals 1, okay, this is the part of the graph at x equals 1. So how does the tangent line look like? So it looks like that. So what is the equation of this tangent line to this parabola at x equals 1? So to find the equation of the line, we need to have one point on the line. So we should identify the coordinates of this point. We already know the x coordinate of this, which is 1. And then we need to solve for the corresponding y value. And then, since we will use this equation, we need to find the slope of this tangent line. And this tangent line is the limiting position of all the secant lines. So we will use also this formula for the tangent line. So the slope of the tangent line is the limit of f of x minus f of x null over x minus x null as x approaches x null. So these are the two equations that we will use in solving this problem. Later on, if you have already the differentiation rules after the derivatives, then you will have a shortcut for this slope of the tangent line. So this time, as we start with finding the equation of the tangent line, we will use the concept that tangent is the limiting position of all the secant lines. So this is the formula for the slope of the tangent line. Okay, so we are given here that x is equal to 1. So this one is the x null. Okay, so that's the x null. So we will solve for f of x null, so or that is f of 1. So since our f is x squared plus 1, replace x with 1. So you will have 1 squared plus 1. So 1 squared is 1. 1 plus 1 is 2. So this is the y value when x is 1. So as what you can see here also on the graph, that's 2 here. Okay, 2, the y coordinate. So we have a point 1, 2. So we will use that later here, that x null is 1 and y null is 2. So let's go back to this formula of the slope of the tangent line, limit of f of x. So f of x is x squared plus 1 minus f of x null, as what is solved here is 2. So minus 2 over x minus x null, which is 1, as x approaches 1. And then if you will simplify the numerator, 1 minus 2 is negative 1. So you have here, you will apply your technique in solving indeterminate form of type 0 over 0. Because if you will substitute directly here 1 to x, you will have 1 squared minus 1, that's 0. 1 minus 1 is also 0. So 0 over 0. So you can factor or rationalize. Since we don't have a square root here, so we will factor. And in the numerator, we have x squared minus 1. That's difference of squares. So if you will factor that, you will have sum of difference of the square roots of this term and this term. So square root of x squared is x. So you will have x. And then square root of 1 is 1. So you will have a minus and a plus. And then copy the denominator, x minus 1. So you can cancel this, x minus 1 and x minus 1. You will be left with limit of x plus 1 as x approaches 1. So this will be canceled and this. So we will be left with x plus 1. So limit of x plus 1 as x approaches 1, we can already substitute. So that's 1 plus 1, which is 2. So the slope of the tangent line to this parabola is 2. So the slope of this red line here is 2. And then we already have m, and then x null and y null. We already have. This is the point slope form of the equation of the line. This is the formula that you use if you're given with the slope of the line and a point on the line. So probably you have learned this when you were in grade 8. So let's substitute the values. So y null is this one, 2. M is 2, this one. And then x null is 1. It's given. And then you can already have this as your final answer if your teacher asks you to write the equation in the point slope form of the equation of the line. But if your teacher demands that it should be in the slope-intercept form, or that is y equals mx plus b, we have to still do something. We have to write it as y equals mx plus b. So you can distribute 2. So 2 times x is going to be 2x. 2 times negative 1 is negative 2. And then this negative 2 here, if you put on the right, it's going to be positive 2. And then negative 2 plus 2 is going to be 0. So you will have y equals 2x. So the equation of this tangent line is y equals 2x. So what we did here first was we identified y null. That is by replacing x with the value x null here, so that you can have a y null here. And then solve for the slope of the tangent line using this formula. And then after that, you can already substitute here m, x null, and y null. And then write the equation in slope-intercept form, or y equals mx plus b. Okay. Let us have the same equation, but this time at x equals 0. So at x equals 0, we have it somewhere here. So at x equals 0, that's the point. So if we look at it, we're expecting that the y is going to be 1. Let's check that later. And then the tangent line looks like that. So this is the tangent line to the parabola at x equals 0. So what is the equation of this line? So still, we will use the point slope form of the equation of the line. And then this formula for the slope of the tangent line. So x null is given to be 0. So solve for f of x null. Replace x here with 0. So that's going to be 0 squared plus 1. So that's 0 plus 1, which is 1. So this is now our y null, or f of x null. And then solve for the slope. So substitute f of x is x squared plus 1. Just put it here. Minus f of x null is this one, 1. Over x minus x null is 0. As x approaches x null, or 0. And then the numerator, 1 minus 1 is 0. It's going to be x squared over x. And then if you will substitute 0, you're going to have 0 over 0. So you can cancel. Okay, so x squared divided by x, you will have x over 1, or x. So limit of x as x approaches 0 is simply 0. So we have the point 1, 0. So here, our x null is 0, and our y null is 1, and our slope is 0. So we have y minus 1 equals m, or 0, times x minus 0. So you will have y minus 1, and then 0 times x minus 0 is 0. And then transfer 1 to the other side, it's going to be positive 1, so y equals 1. As what you can see here, it's indeed a horizontal line, okay? Slope is 0. So y equals 1. So this is the equation of the line that is tangent to x squared plus 1 at x equals 0. Okay, another example. So find the equation of the tangent line to f of x equals x minus 2 at x equals negative 1. So f of x equals x minus 2 is a line. So at x equals negative 1, it's here. And then let us solve. So what is the equation of this tangent line? So y minus y null equals m times x minus x null. That's the point slope form of the equation of the line. So let's solve for y null. So x null is -1. So f of x null is -1 minus 2. Just replace x here with -1. So -1 minus 2 is -3. So this is our y null. Okay, so the slope is the limit of f of x is x minus 2 minus y null is -3 over x minus x null -1. Simplify. -2 minus -3 is +1. So that's going to be limit of x plus 1 over the denominator is also x plus 1. Or if you can cancel, that's going to be 1. So x plus 1 and x plus 1. Because if you will directly substitute, it's going to be 0 over 0. So cancel and simplify. That's going to be 1. Limit of 1 as x approaches -1 is 1. So we already have our values of m, x null, and y null. So we can put it here. Y null is -3, so replace it. And then m is 1, this one, m. And then x null is -1, so this one. So y minus -3 is y plus 3. And then 1 times this is x plus 1. So put 3 to the other side, you're going to have -3. So y equals x plus 1 minus 3. So that's y equals x minus 2. So as what you can see here, y equals x minus 2 is the line tangent to the line y equals x minus 2. Because actually, the tangent line to a line is the line itself. It's always like that. Because the limiting position of all the tangent lines will be approximately, will be the same as the line. Because anyway, all the secant lines are also uh, this line. So it's going to be the same line. So next time, if you're given with the equation of a line, and then you're asked to find this, the equation of the tangent line, then just write the line itself. You don't need to solve at any value of x, wherever it is. At x equals 1, at x equals 2, it's going to be the line itself. How about this? Find the equation of the tangent line to f of x equals square root of x at x equals 1. So square root of x, f of x equals square root of x looks like this. At x equals 1 is here. So the tangent line looks like this. What is the equation of this line? So same process. First, solve for y null. Y null is the y value when x is x null. So f of 1, so square root of 1, 1. Slope, f of x is square root of x, f of x null is 1, here, this one. So put it there. Over x minus 1, as x approaches 1. And as what you can see here, if you will substitute directly 1, you're going to have square root of 1, that's 1 minus 1 is 0, over 0. So rationalize. Let's rationalize the numerator by multiplying square root of x plus 1. So if you have a minus here, you multiply a plus. So same terms, but instead of minus, plus. So that you will have, if you're multiplying difference and sum, you will have difference of squares. So if you have difference of squares, the square root, square of the square root is going to be simply x. So the numerator will be rationalized. So, square root of x minus 1 times x plus 1 is going to be x minus 1. That's by multiplying difference and sum, you will have difference of squares. What is the square of square root of x? X. What is the square of 1? 1. So, x minus 1. And then for the denominator, just copy x minus 1 times square root of x plus 1. And then after that, you can already cancel x minus 1 and x minus 1. So you will be left in the numerator with 1 over x square root of x plus 1 in the denominator. And then from this, you can already substitute 1 over square root of 1 plus 1. Square root of 1 is 1. 1 plus 1 is 2. So 1/2. So the slope of this line here is 1/2. And then substitute it here. So y minus y-null. Y-null is this. Equals m, 1/2 is this one. Times x minus x null. This is x null given 1. So you really have to remember these two formulas, this and this. So you can distribute 1/2 here. 1/2 times x is 1/2 x. 1/2 times -1 is -1/2. And then this -1, if we'll put to the other side, it's going to be +1. And -1/2 plus 1 is +1/2. So you will have y equals 1/2 x plus 1/2. So this is the equation of this tangent line here to the graph of f of x equals square root of x at x equals 1. Okay, another example. Oh, we have the same equation, but this time at a different point at x equals 4. So at x equals 4 is this here. So same equation. So the tangent line looks like that. And then solve for y null. So y null is square root of 4. That's 2. And this 2 is what we will use here in this f of x null. So f of x is square root of x minus f of x null is this one, 2, over x minus x null. So what we're going to do is we will multiply square root of x plus 2 so that the square root in the numerator will be gone. So you will have square root of x, square root of x times square root of x, or the square of that is x. And then the square of 2 is 4. So you will have the difference of the squares. Since we're multiplying a difference and a sum of two terms, the result or the product is the difference of the squares. And then for the denominator, just copy x minus 4 and square root of x plus 2. Because you can cancel x minus 4 and x minus 4. So you will have 1 in the numerator left over square root of x plus 2. And square root of x, you can already substitute there. That's square root of 4. So that's 2. 2 plus 2 is 4. So the slope of this line is 1/4. So we can already substitute. Y minus y null is 2 equals m is 1/4 times x minus x null is 4. And then distribute 1/4, you will have 1/4 x minus 1. 1/4 times -4 is -1. And then the minus 2 here, you put to the other side, it's going to be +2. So -1 plus 2 is 1. So you will have y equals 1/4 x plus 1. So this is the equation of this tangent line to the given graph at the given value of x. Okay, so that's it for now. Next time, we will have the equation of the tangent line. We will solve it in a shorter way because after you know how to find the derivative of the function at a certain value, then the computation for the slope will be faster. But still, we will use this point slope form of the equation of the line. So that's it for now. I hope that you learned. Continue to support FatMath TV by subscribing and watching the videos. I hope that this video helped you. So see you in the next video. Bye.